With the AI assistants, it was prompt and the rest. Now with the agents, they're calling APIs, they're calling MCPs, and they are triggering workflows and taking actions on your behalf.
The risk has shifted from passive data exploitation to active, unauthorized, remote execution, which are driven by these agents. These agents are authenticated, like running on my behalf or on a genuine employee's behalf, but you do not know whether the agent can go rogue.
Chat is, read mostly. The worst case is you're getting a bad answer back. But with the agents, you're actually seeing more action, calling APIs, triggering workflows, writing to a system, poisoned inputs that turn into unintended actions. Every input as potentially hostile and every action is potentially dangerous.
Number two is to ensure that the sensitive data is not going to LLM. Look at the request and the response and the meaning.
Hi, I'm Ahmed Kanagrash. I'm the founder CEO of Protecto. Welcome to another exciting episode of AI on the Edge. I'm excited to welcome Komal and Brian from Citrix NetScaler. Komal is the Director of Product Management for NetScaler. He has spent years helping enterprises modernize application delivery across Kubernetes, cloud-native infrastructure, observability, and automation. Most recently, Komal led the launch of NetScaler AI Gateway, helping enterprises govern and secure AI-powered applications at scale. Joining him is Brian, Senior Product Marketing Manager at NetScaler. Brian works closely on NetScaler's AI Gateway's messaging, customer enablement, and go-to-market strategy. They are the perfect guests to help us unpack how AI gateways are evolving from a traffic control to enterprise AI governance. With that, Komal and Brian, welcome you both in this conversation.
Thanks so much for having us.
I will start with a quick icebreaker. So every day we wake up with all kind of exciting news about AI. In the past few weeks, pick one AI development that you're most excited or most surprised about. Love to hear your thoughts on that.
Yeah, I'll go ahead first.
Yeah, sure.
Instead of one, I'll talk about two. And one is about, actually, there is sort of a Cambrian explosion of new tools, new startups, new ways of doing things with AI. So that's very exciting. And then the second one is on the business side, where we are seeing that the budgets are getting released. There is more investment on the AI side. Obviously, there is investment for startups, but inside bigger companies also, like within Cloud Software Group, within our customer base as well, there is a investment to use more AI and show productivity gains and build tools which were somehow which the teams were not able to build in the past because of resourcing constraint or because of tooling constraints, etc. So it seems that we are in that very new phase where people are being given the license to develop and build more things and show what they can do with AI. And this cuts across the organization, engineering, product, design, and so on.
Mm-hmm. Great. I mean, that's a good news for all of us, I guess. Okay, good to hear that. Brian, how about you?
I would say it's not so much a product development as just a development that happened in the wild. I think that the Pocket OS having its database and backups deleted in 9 seconds, that was very interesting. I think it did a lot to show that people think, a lot of the built-in protections might be enough. They're using, a strong model like Opus, and then next thing you know, your database is gone. So I think that it's starting to validate the need for some centralized controls, point protection solutions.
But that highlighted the issue of how agents are different than applications. They can take an action on your behalf, much more powerful. Yeah, that takes us to the main part of our discussion. Companies had firewalls, API gateways, WAFs, and other kind of traffic controls for years. But when it comes to AI traffic, when it started flowing into enterprise networks, what changed, what broke, or what security gaps starts emerging, and what teams were expecting or weren't expecting? I'd love to get your thoughts on from that perspective. Brian or Komal, you can go first.
Sure, I can give a bit of a high-level opinion, and then Komal, why don't you take it from there? So I'd say that a lot of the controls we already had, such as firewalls, API gateways, stuff like that. It's built to inspect a lot more of the structure, such as ports, protocols, signatures, known schemas, and things like that. And the AI traffic has created, this unstructured natural language approach in both directions. So the risk means it's a lot in the meaning, not so much the syntax. And I think that what's different from a lot of the prior waves we've seen is before a lot of sensitive data would stay in the system you own, but now you have a lot of users pasting potentially sensitive data into a model which is going to be outside your perimeter, and it answers back in a text. So the exposure is in the content, just as much it is in the connection.
True. Komal.
So I would add to what Brian just said. He was saying that instead of syntax, now semantics matter more, which is absolutely the case, because two completely different prompts could mean the same thing, could return the same output. So semantics matter. On the technical side, I think although it is all HTTPS traffic, and we are primarily talking about the traffic coming from agents and users to the large language models. We're not talking about how the models get trained or how the inference is optimized. But only on the inference side, it's still HTTPS traffic. That's the backbone of it. But I think that the profile or the nature of the traffic is changing. Earlier, there were humans who were accessing these applications. So it used to be the humans used to be the rate limiters. But now agents are accessing it. And also the responses and the responses are streamed, which means that the responses are really long and they come over a span of time, because the agents and because the large language models do not give the response in just one shot. There is a lot of wait time, there is a lot of planning, reasoning time, and then the responses come. So as a part of that, all the networking components in the path, like the AI gateways, the load balancers, and the firewalls, they have to respect that nature of this new traffic, and that's how new requirements are being expected from all of these components, like load balancers or application delivery controllers or firewalls and so on. So that is a subtle technical change, because of which HTTP3, because of which post-quantum cryptography, these kind of things are getting more vital rather than just plain HTTPS-based load balancing.
That's a very interesting point you bring up, Komal. How the sessions are longer. It is not like I do a search and get a bunch of results, or I access my email, I see my email. Those kind of the traffic is very different than AI. Where I ask a question, I can spawn a workflow. It might think for a few minutes, a few seconds to respond, and I can pick up the session later. So these kind of complex workflows are having a different impact on the overall how the networks is being treated. That's a very important point. If you can double click, it will be very helpful. A little bit more technical is fine. Why this traffic is different. You touched on HTTPS and how this less long sessions. A little bit, if you can give color, that'll be very helpful for the audience.
Yeah, absolutely. So, and it's not really completely new. We have been sort of touching this aspect. So when we interact with interactive websites like sports website, where we are on that page, but the score keeps getting updated over like hours or over multiple, sometimes in terms of cricket, multiple days as well. We're on the same page, but the HTTPS connections are long-lived. Those are SSE, server-side events that get streamed from the server, essentially on the same HTTP connection, and that connection is typically maintained by an ADC or application delivery controller. You can also call it like load balancers or ingress controllers in case of Kubernetes deployments. But essentially, the reverse proxies or the ADCs in the path have to make sure that these connections are delivered faster, delivered in an optimized way. If your backend servers are really high class and modern, but your ADCs are not modern, then you just lose the whole benefit of these type of SSE connections. So the same thing is being used as part of AI traffic as well. A lot of the connections that are there from our Claude Code agents or from our Visual Studio Code or from our GitHub Copilot to these large language models. The large language models at the backend could be public cloud hosted, or these could be self-hosted. All this traffic is this HTTPS SSE based connection, and that's where the role of up-leveling your infrastructure is vital. The other class of traffic is the MCP traffic. We'll touch upon that little later as well. MCP stands for Model Context Protocol, which is actually making these AI models and the interaction smarter, because MCP allows you to leverage the databases and the applications that are corporate without like the data going to the LLM. Okay, so that's the important part. So this type of traffic is also again HTTPS based, but it's all using the modern HTTPS paradigms. So that's why the HTTPS, HTTP3, Quick, gRPC, these kind of technologies which were esoteric 3 years earlier, but those are like very important nowadays.
Fantastic. That brings to the next topic. You touched a little bit on this, but I'll go a little deeper. With the AI assistance, it was prompt and the response. I ask a question, I get a response from ChatGPT, or it can be any AI assistant. It is more of a chat interface. Now with the agents, they're calling APIs, they're calling MCPs, and they are triggering workflows and taking actions on your behalf. So how does this change the risk picture, right? From previous, yes, data can leak and I'll get the answers, but it is a limited one path, like I can prompt a response. Now I have multiple interaction paths. And how does this change risk picture from your perspective? Komal, you can start with that, then Brian, feel free to jump in.
Yeah, actually, I'll link it to what Brian said in the beginning. So that framework is very useful, like semantics and syntax. So till now, we have been ensuring security is at a syntactical level. But now the security has to get deeper into semantic level, because now the risk has shifted from passive data exfiltration to active, unauthorized, remote execution, which are driven by these agents. And these agents are authenticated. These agents are like running on my behalf or on a genuine employee's behalf, but you do not know whether the agent can go rogue and why and how. So these kind of semantic security checks and security risks have developed, and because of that, the security solutions also need to be used, which are understanding the semantics, not just checking the key value pair and ensuring that the key, the value in that particular key is safe or not. Brian, you would want to add something to it?
Yeah, I would just add that, it really does change the picture a lot, because the blast radius is going to change. Chat is, read mostly. The worst case is you're getting a bad answer back. But with the agents, you're actually seeing more action, calling APIs, triggering workflows, writing to a system. And I think that what's interesting here is that you can end up with, poisoned inputs that turn into unintended actions. These agents tend to operate with a lot more privilege than potentially even the user behind it. And what can be tricky is you don't have like a clean audit trail to figure out what happened and why. So I think a big part of dealing with that, is treating every input as potentially hostile and every action is potentially dangerous. And that kind of, help you close the gap with, more least privilege, scoped tokens, and, human review where the blast radius is large. So I would say that, obviously solutions to that, having a governance layer, but you also want to make sure you're understanding it's a systems problem. You want to make sure you're making sure you're enforcing at the audit point, and also trying to resolve the full answer if you can.
Yeah. Is there any actual failure modes that people are not thinking through this new paradigm? If you want to double click, that would be very interesting too. Hey, we always think about this way, like what you briefly touched upon. People are worried about data leaks, but hey, now we can take actions. So you have to think about these kind of risks. So if you can highlight any of those risks, that'll be helpful too, right? People haven't fully thought through yet in terms of agents and actions.
Yeah, sure. I think it's a bit kind of what we spoke on before, and then Komal, you can kind of chime in here, as I'm sure you have more experience in the area. But I think that the fact that you're dealing with what is potentially untrusted input by design, you're just dealing with failure modes that teams haven't really worked through, such as that, the indirect prompt injection, and kind of that result of unintended actions.
Sure. So go ahead, Komal.
Back to what Brian was saying, that I think the number one thing that I've seen from our customers is that they want to use AI, but they do not want to send sensitive data, like important files, important information, or even if the users are naively sending some sensitive data to the LLM, they want the AI gateway or something in the middle, a bump in the wire, to check and not send it. So that's very important because while they want the velocity of AI to be used, but they do not want to be like in the front pages of dark hackers' website that something important has leaked to these models.
True. All these companies, they also have compliance regulations, data sovereignty laws, internal legal policies, what they can share with external models or agents. And that also is a big constraint on what they can share with a model or an agent. So if I have to double click on this one further and say, you mentioned that, hey, this AI gateway and a couple of times. So let's start with NetScaler has been handling enterprise traffic for the last 2 decades, 20 years, right? Now it is evolving, or in some sense with our collaboration on the AI gateway, now it is evolving into a AI deployment or more like an AI gateway in that path, right? So what can NetScaler do differently, or what power does it have that others may not have when it comes to AI gateway? Because AI gateway, many are releasing who are not as experienced as Citrix. So how do you see this, your traditional strength, and how the gateway is helping you?
Yeah, Brian, I'll go first, and I'll try to be short because this is an answer that I could just take out like half an hour just to answer it.
Please, we'll go deep.
Okay, so if we take a step back, like NetScaler has been there since like the internet became internet, 2000, early 2000, late 1990s, and we started our journey with TCP load balancing, HTTP load balancing, TLS termination upload, web application firewall, content switching so that the traffic from mobile and desktop traffic can go to different websites. And then over the years, a lot of technology waves came, virtualization, multi-tenancy, public cloud, containers, and now AI. So NetScaler is a product that helps the networking admin, the IT admin, to make sense of all of these important fundamental networking technologies and these paradigms, and make sure that the applications comply to these paradigms, to these infrastructures, and without impacting the performance. One of the most important things that we learn from our customer why they use NetScaler is that they get all of these things done together in a single pass architecture. They do not have to deploy 3 different point products. If you go to public cloud, you have to actually instantiate 6 different services to get these things done. And that is like 6 different teams, 6 different builds, 6 different configurations. And if you have to upgrade, then you don't know whether the configuration is in the 3rd or the 4th service. So while this space has exploded, but NetScaler is really firmly rooted into these important aspects. And in fact, even yesterday, there was a presidential order, executive order from the White House about the importance of post-quantum cryptography, that now every organization has to have a post-PQC strategy, and that they have to report into their industry leaders. And that is also a fundamental component of NetScaler. So these are like really important things without which an application is just a toy application. It cannot become a production grade application. Now we are seeing an explosion of AI gateways, which is a very good thing because more startups coming into this area means that this is a valid market. There is a deep need for it. In fact, even Anthropic itself has on their documentation mentioned the need for an LLM gateway if you want to roll out Cloud Code for enterprises. So if you want to just use Cloud Code as an individual user, go fine, use it. But for enterprises, if you really want to reap the benefits of Cloud Code, you need an LLM gateway. So that's like about NetScaler and the need for an AI gateway. Where we can really connect the dots is that because of our single pass architecture, we can perform these important AI gateway functions in just one go. We can take a look at the HTTPS packet, open it, do all the processing related to routing, to load balancing, to AI gateway functions, which we can discuss a little bit later, and then send that traffic to the backend large language models or to MCP servers, or choose to drop it because we found something suspicious because of our partners like Protecto. that note this prompt had something, some of the confidential information, we should not send it to LLMs. So that's a short answer. I'll let Brian also chime in.
Yeah, no, I've definitely been inspired by that. There's a one thing I want to talk about first, though, and I think that it's that lock-in. Many of the major LLM providers offer their own AI gateway solutions, but the catch is that their gateways really only govern traffic to their own model. So if you build your governance framework around, say, Azure's AI gateway, and then later decide to bring in models from AWS or something, you essentially have to start from scratch. You need to rebuild the policies, rate limiting, security controls, all of it for this other platform. But with NetScaler, that problem doesn't exist. You have one policy framework governing all of your AI traffic, regardless of which LLM providers you're using or where they're deployed. The second one, Komal, he touched on the NetScaler single pass architecture. And I think an important thing to mention on that is the nature of AI traffic itself. So AI workloads are fundamentally more volumetric than your traditional application traffic, both in terms of the amount of requests you're seeing, and then also the size of each individual request. The payload sizes are larger, the token processing can be very compute intensive, and as the conversations continue and lengthen, the number of API calls can scale very rapidly, as well as when AI workflow adoption grows as well. So this really means that controlling the latency and the CPU utilization is more important now than ever. And then that's exactly why what Komal mentioned with the single pass architecture becomes critical. So this is something that only NetScaler offers in the ADC industry. And to showcase how strong it is, we've actually done third-party independent performance testing of NetScaler versus other top vendors. If you're interested in seeing the results, you can look up a NetScaler Tally report, but we don't have to go into too many details here, but it is very shocking. As you stack on more requests, as you're stacking on more things to do, such as WAF, bot inspection, content, header inspection, that type of thing, it can really increase the amount of compute intensive needs on the ADC. So we play really strong there. And then another thing I wanted to mention is the deployment flexibility. I think that the fact that NetScaler runs on a single code base for on-prem, cloud, hybrid, that means whether you're running things locally or a mix, the experience, policies, and the management all stays consistent. You have a single pane of glass with NetScaler console, giving you that centralized visibility and control across every deployment. And I kind of touched on the fact that you can have it as hardware, you can have it as software in the cloud. You can also have it same code base, whether you're running our Linux-based deployments, whether you're running it in a container with our Kubernetes-based deployments. So it really allows you to have that freedom to use it wherever you want to while still having that consistency for whatever you're trying to do. And then I think Komal kind of mentioned at the beginning, but this isn't built from scratch, unproven. It's really on top of a leading ADC infrastructure that a lot of people have relied on for years. So we're just extending those same strengths we've already had, performance, reliability, security, into this new AI era.
So it's a natural fit, if I have to summarize in a way, it's a natural fit to what you already do. You have the years of experience, you have the ability to see the traffic, one pass you can handle, and one single pane for the entire organization to manage, and how they take the risk, or how they manage risk in AI traffic. That takes us to the next topic. That's where Protecto and Citrix, we have been collaborating for the last few months. Thanks again for the collaboration. For the audience, a little bit of context what Protecto does. Protecto is a data security for the runtime, AI runtime. The way to think about it is when you're doing agentic AI or any kind of AI workflow, you are sending your enterprise data, right, through models, through MCPs, tool calls, and these have PII, these are personally identified information, or PHI, patient health information, or business confidential information like discount details, HR information. There are a variety of information that can flow part of this AI workflow. And in that workflow, not everybody is allowed to see every part of the data. In some cases, some banks are not allowed to send certain information beyond their geographic boundary. This is also called data sovereignty. So each organization have their own constraints. This is where NetScaler and Protecto came together and launched an integration a few months back. So what it allows the customers is to way to manage their or govern their AI, the data flowing through AI workflows. And with that introduction, I will jump deeper into this conversation. Hey, thanks again for the collaboration. From your point of view, how does this partnership help your customers, or how is it changing? We are talking about data flowing through prompts, responses, tool calls, and NetScaler handles the network traffic visibility and governance layer. And combined with that with Protecto, how is this helping customers? What gaps it's addressing? If you can tell from your point of view, then I can also add a bit about from Protecto side.
Yeah, I'll take a stab at it first. So what we are seeing is that I see the list of requirements that come from some of our customers, and those requirements come in two categories. One is the core traffic management category, and then the second one is on the security side. And I see that the security requirements are mainly derived from the OWASP top 10 for LLMs and OWASP top 10 for MCP. Like there's a variation of those requirements only. That, for example, they want to prevent prompt injection, they want to prevent jailbreak attacks, they want to ensure that the secrets are not exfiltrated. But the requirement that is right there in number one or number two is to ensure that the sensitive data is not going to LLMs. That is one of the most important requirements because AI can make mistakes. Okay, so that's why we get this requirement at the top, and for that, going back to Brian's original answer, this is not a syntactical solution. This is a semantic solution, where you have to look at the request and the response and the meaning of it and figure out whether a PII or whether a confidential data or a API token is going to get through this or not. It's very difficult to do it through deterministic or syntax checks. So that's where Protecto-like solutions are very important. Without this, customers are taking a lot of risk.
Mm-hmm.
Thanks.
Yeah. I would just add, just a little addition, but Komal pretty much covered it. With NetScaler handling the network and the governance layer, we can route the request, enforce the policies. We can have prompt templating, rate limiting, logging everything. But what Protecto does is critical. They close that gap on the content level inspection and the de-identification. So you kind of mentioned it, being able to detect PII and redact it as well, or PHI, as you mentioned before it reaches the model is critical. And then the thing I would add on top is kind of the 1 + 1 = 3. Because of the way NetScaler AI Gateway has built this extensible integration framework for layered security, it makes it very easy to plug Protecto into the, that centralized governance you already have. And then, it's a seamless integration for all your AI workloads, as opposed to having to rebuild it based on each application you have too.
Oh, fantastic. I mean, this gives a very good overview of where we fit in. The framework of semantic is syntax, both Brian, Komal, both of you touched. It's a very important thing to understand, because in the AI world, the semantic meaning determines what AI reasons, what AI responds, what tool it calls. Yeah, simple redaction or simple change could affect the semantic meaning that will result in a completely different answer and action. So we have to be very careful. That's where Protecto's differentiation also plays in, understanding what is the context, what is the content, and within that, what is sensitive, and when we are masking, tokenizing, redacting. So how does it impact the meaning of the data? And hence, how does it impact the downstream AI steps and AI reasoning? How do you maintain the context across these whole AI workflow? Is a critical problem. That's one of the AI Protecto's differentiation. How we will protect your sensitive data without impacting the semantic meaning. Hence, your AI reasoning and other parts of AI remains intact. So that brings the best of the both worlds. Hey, here you have the gateway or the whole power of NetScaler along with the gateway, and we have a Protecto joined together to help our customers solve this complex. protecting sensitive data in AI workflow kind of problems. This was a fantastic discussion we had for last close to half an hour. So we are near the end of this conversation. So I'll end with this question. Let's say, a lot of security professionals, CISOs, AI engineers are listening to this podcast and will be eventually listening to this conversation. If you had to give a practical advice, somebody is planning to roll out an AI application in 90 days or 3 months, in a month, what are for this sake, let's assume it's an internal application for internal users. What are the things they should be doing as the first steps or the broad strokes and also immediate first steps that will help them secure? And you can tell from hey, if you are a NetScaler customer, this is what you should do, versus, hey, if you're not a NetScaler customer, what are things you could do? Both will be very interesting if you give that perspective.
I can start with this one and I'll let you finish it off, Komal. I would say that obviously the first thing you want to do is get some visibility, know what AI is already in use, what, your rollout's going to touch, where you're hoping to expand to. The second thing is really about establishing that single control point in the data path. You obviously don't want to let traffic run straight to the LLMs anymore. As we've talked about, there's a lot, at risk here. You want to be routing it through a gateway to have that level of enforcement and governance. And I think a big factor here is, we've seen Claude Code as one of the most popular use cases lately. And for example, with NetScaler AI Gateway, being able to have a level of control over, the governance on all requests, regardless of which provider is serving, the backend requests for Claude Code is critical. And additionally, being able to use your own authentication methods. You can use your company's own SSO. It can be a big ask for your developers to have to always build it themselves for each of the built-in Claude Code, provider gateways as well. And then finally, I'd say is making sure you have that layered content protection at the control point. So as we mentioned, having some PII or PHI masking or redaction, so the sensitive data never leaves our phone.
Awesome.
Yeah. Just to add to what Brian said, based on my experience of helping a few customers who are rolling out AI applications into production, the typical journey that they take is obviously they will evaluate whether the products that they're choosing check most of the boxes or not. But when they start the proof of concept, they put an AI gateway in the sandbox environment, in a Google Cloud VPC or on-prem environment. And first thing that they do is just do a reverse proxy of the LLMs, that you do not let the agents or the users talk to LLM directly. You just intercept that through a reverse proxy. And then you do let the reverse proxy or the ADC or the AI gateway, there are various names for it, but you let the AI gateway do, first of all, the logging of the prompts and the responses. That can you see what is the user or the agent asking for and what is the LLM sending. So once you have that baseline set where you are able to see the prompts, the responses, the token consumption, the cost, then you know that the AI gateway is working fine fundamentally. And then you layer on other capabilities. For example, you want to add authentication, like Brian was saying, that rather than a user getting direct access, I want them to authenticate through corporate or SSO, and that is a part of AI gateway. Then you layer in security capabilities, like I do not want to send PII information, so integrate with solutions like Protecto. Then you do advanced AI security controls like prompt inspection, jailbreaking, and so on. And somewhere along this also comes MCP, where you would want to layer these security policies for the MCP traffic as well. And we see that customers typically choose either two products or single product, either the ingress controller plus the AI gateway, or like NetScaler, if a product like NetScaler provides both of these things, then they would want to combine all of these things together. Because it's important that to know that while we're only talking about the functionalities of AI gateway, there is another dimension which is non-functional requirements of AI gateway. Like, will it scale? Will it work on different environments or not? Kubernetes, virtual machines or not? Whether we'll be able to get the syslogs and all the logs in the Splunk of the world or Google Chronicles of the world. So there are a lot of these non-functional requirements which the AI team may not know, but the networking team knows because they have been doing this for the last 20 years.
True.
So that's
This-
what I think small answer is.
Fantastic. Hey, this was very insightful conversation. I learned a lot. So I assume our audience also learned a lot. So this recording will be available on LinkedIn, and we'll also publish it on YouTube. And audience, if you have any questions, please post it on LinkedIn, and one of us will answer it. With that, thank you, Komal. Thank you, Brian. Thank you for your time. Thank you for the collaboration. We're looking forward to working with you closely. Thank you.
Awesome. Thanks so much for having us.
Thank you, everyone.